Yeah, can I say one?
Go for it.
Hey, Walker, it's too bad that you couldn't be with us because we're surfing on sine waves right now.
So,
Also, the
Hey,
Mets
Walker,
lost.
I was gonna say
Yeah.
that.
Let's go Royals!
Okay.
Let's go Royals!
All right, Jordan.
Gotta work.
Okay, so, yeah. Are we ready? Are we? I'm kind of just want to like,
Obviously.
Oh, mode check, guys.
good call. Yes, you do need that. Okay, so lengths of curves. We want to be able to take a curve from one, and it's got to be on a closed interval, and if we were to kind of stretch it out, how long would that be? So it's definitely going to be longer than 2 pi, all right? But how long is it? And let's talk about, so how do you think we could get the distance between here and here? If we stretch it out. Any ideas? There's going to be something with a derivative. It has to do with, let's say I want to find from there to there. Okay? Mini triangles. So basically, let's say this is P and this is Q. So if I make like, if I make a line connecting them, okay, I can create a triangle, a right triangle. So this is like the change in X. This is the change in Y. And so what would the hypotenuse be? It would be your hypotenuse, right? So
Our derivative is delta y over delta x.
So this would be the square root of delta x squared plus, okay.
Thanks, Pythagoras.
Now, this is just one segment. Imagine if we created infinitely many of these small segments, right? We get a limit. We basically are adding up infinitely many of these over the entire curve. So we're going to integrate that. Now, so we are going to take the sum of all the delta x sub k, so that just means all of them.
We never did sums.
We did, but remember when we wrote sum, it turned into an integral. Okay, so sum, the integral sign means adding up all of this.
What is the k?
That just means adding up all the little line segments. So I didn't want, there wasn't a lot of room to draw in that picture, but imagine that, see how we have in this picture, I just wrote one, delta, this was delta x to delta y, but if we have infinitely many of these, that's why I just put a sub k, because it just represents all of them over this entire curve. Okay? Now, there's a proof to derive the formula. It's in your book. I even wrote down at the bottom here. It says on page 413. If you want to look at it, go for it. I'm not going to prove it for you. No, I'm just saying if you want to see the proof for it, right. If you want to look at it right now, it's on page 413. In the meantime, I'm just going to show you it. So these are the two formulas, and you'll notice there are two because one is if you have a function of x, and this one is if it's a function of y. Okay, so the one is if your graph is defined in terms of x, Like if it's y equals x squared, we would use the first one. Okay? Maybe I should write that down. So if I'm trying to figure out the length of y equals x squared, I'll use this one. But if I were going to find the curve of y equals cosine of y, I would use the second one. And notice that it's the opposite. This one has dy dx. This one has dx dy. Okay. So now we will be taking derivatives with respect to y in this lesson, which we've done before with implicit differentiation, but this isn't going to be implicit differentiation because it's dx dy. You'll see an example. Okay, so we're going to go back to that first page. I don't know. You can look it up. Okay. Implicit differentiation is when, like if you have x squared plus y squared equals 4, when you do d dx of both sides. Yeah. Okay. So if this, remember, what's our formula? So we're going to use this one. I'm just going to write out the formula. So here's y. Before I plug everything in, let's just take this and find dy dx, which is, derivative of sine is cosine x. So the length of my curve is going to go from where? Right? And what's A and what's B? So I have 1 plus cosine squared of x dx. Right. Now, if these are going to be calculator okay problems, there are just a very few that you could actually do by hand. This one we cannot do by hand. Why not? Because, yeah, and we have cosine squared, so somewhere we would have to have, like, a sign on the outside or something. Yeah, or a calculator. So this is a calculator okay problem. Yes, Lindsay?
Are there always going to be balanced derivatives?
Yeah. Because when they're asking you to find the length of the curve, we have to have, like, the beginning and the ending point.
And this is,
Notice there was something on the board.
this is as hard as it's going to get, right?
The next ones, the next two problems are a little more difficult. What is it, 9?
7.64?
Ooh, I think I got 9 point.
So I can't even use a calculator, right?
Yeah, 7.6.
Oh. What did we get? Did I write it down wrong?
I just plugged in math 9, 0.25. I'm in radians. And then since I can't.
Did you do square root?
Yeah, put in square
Oh.
root.
And what did you get?
I'm in radians.
Okay, what did you?
Calculator.
1 plus
Hey, Mojo, you missed
cosine x
Yeah,
squared.
and what did you say you got?
I got like 7.64, but now I'm doing it again. And
6.
Error in syntax because I forgot to put dx.
He is over it. No, I'm just exhausted. Oh, I'm completely worse week of all.
Anybody else?
7.64.
6 4 what?
039.
I got 7.64.
All right, then I have.
I wanted to use this so bad.
Oh no.
I'm rounding to 2 decimal points and spending too much time.
Okay.
Oh, poor you.
I'm completely kidding.
Okay.
For your woohoo parties.
Good.
Never been to a party.
Okay, so these next two are going to be without a calculator.
Oh, I love you.
So-
You're kidding.
Not kidding.
By
So
the way,
first,
no calculator.
let's just find dy dx.
I
Oh.
still find that.
Oh, in this case, mine doesn't say no calculator,
Oh, it's true.
so mine is.
Oh, really?
Yeah, so ours is calculator. Even though yours isn't, ours isn't.
There might be a calculator.
because yours is the one online. I must have revised it a little bit. You'll have to tell me if there's something else different. 'Cause maybe I revised it after I printed it.
Are your pants considered jeans?
Shh.
They look like jeans. Lindsay. They're not allowed to wear jeans.
Okay.
Jeans, they're black. They look like jeans.
No, no, it is. Okay, except for Lindsay.
Sorry.
So what do we write? What are our bounds? 0 to 4. And then we have the square root of. Now, if it helps, you can also, what's dy dx squared?
We don't know. It's 9.
So I have 1 plus 9/4 x dx.
Wait, how?
We go.
Oh yeah, we add that.
Yeah, because it's 3 over 2, so that becomes 9 over 4. X to the 1/2, when we square it, it just becomes x to the first, right?
X to the 1.
Okay, if we can't use a calculator, now this one we can solve without one by u substitution. So if I have u is equal to 1 plus 9/4 x, what's du? And then we're going to change the bounds. What's u of 0 is 1. U of 4 is, yeah, a little bit. Okay, so now I can rewrite this as 4/9 integral from 1 to 10 of u to the 1/2 du. What do we have?
10 to the 1/2 minus 1.
So it's going to be u to the 3/2 over 3/2. So that would be 2/3. So 4/9 times 2/3. And then we have u to the 3/2 from 1 to 10. And yeah, it does get a little messy in the answer. I just want you to be able to simplify it because this could potentially be a multiple choice question with the no calculator. So you want to be able to express this in, simplest form. So this will be 8 over 27, but what do we have? Square root of 10 to the 3rd, so that would be 10 root 10. Do you want me to write that out, or? Okay.
Isn't it the cubed root? No, it's square root of 10 cubed.
Right. So that would be 10 root 10. So you could possibly see your answer written like this, or maybe even distributed. I don't know how far they're going to go. I think this is,
An exact answer like that?
yeah, this is fine. If it says a no calculator problem, then what I was saying is this potentially, could be a non-calculator multiple choice problem. So you should be able to evaluate it. Now, on the test, I'll tell you right now, the problems that I put in for the length of curves are calculator okay problems. Not yet.
Not yet.
The practice test?
No, the real
No, that's not on there yet.
We got this one.
yet? Oh, there. It's going to be on there, guys.
Wait,
It's
there's
all done.
some more shit in the book, yeah.
What's that?
There's book one, too.
Okay,
Tomorrow's just a review day, right?
tomorrow's review and Monday's review.
It's college counseling night.
We have another one of those nights? What?
Tonight's another one?
No, but
What?
still.
Okay, all right, let's do one with respect to y. So you see how this has an x equals? So we want to find dx dy. We've never written it out like this before, so I just want to make sure that we're all clear. If we're taking the derivative with respect to y, I don't have to do any implicit differentiation here. Do you see the difference?
I'll make say dy.
So,
It's no different than doing a normal derivative.
right. Yeah, exactly. Does that make sense why I'm doing it that way? So what would be the first part? It will be y to the 3rd. And then if I write this as 1/8 y to the -2, when I,
Minus.
so it'd be minus 1/4 y to the negative 3. Okay.
We have to split out without a calculator.
There's so many integral equations. I don't know which ones I need to like pi in front of them.
This one's a really tricky one. This one is a lot of algebra in it. I'm going to see if you guys can figure out how we can do this one. What would this look like when we FOIL it out? What do we get?
2y cubed minus 1/2.
Minus 1/2. Y to the 6 minus 1/2 is good. Plus 1/16 y to the negative 6.
How did you do that?
Minus 1/2 what?
It's really hard fact.
That's it, because y to the third times y.
Guys, if you look at when you multiply, oh, what happened to my square? That's weird.
Negative 1?
Oh, I see what I did. When you multiply this, when you square this, you multiply the outside and the inside, you get a y to the 0, y to the 0. So you get a minus 1/4 minus 1/4, which is the minus 1/2. Okay. Do you want me to write it out?
Okay, I get it.
Oh, I can just do the box.
Are you sure?
I don't know how to do that.
Do you want me to write it?
1/4
Outside, outside.
1/4 times
Outside,
they're each
inside,
times
outside,
1.
I can't visualize.
It's the whole.
I'm over at Lindsay's thought.
Oh, and if we combine this,
That's just
so this one is actually a perfect square. So here's, and if you want to write it with a y to the 6 on the bottom, that's fine.
Do you need to write a dy on it?
Oh, yeah.
You also missed the +1.
No, I didn't.
If you went from -1/2 to +1. Oh, well, I missed that.
Okay, I want you to think about,
Y.
I told you there's a lot of algebra in this one.
Oh.
Do you see it?
Plus 1/4
Why
y to the negative third.
It's always going to be
This is a perfect square then. So when we add in the 1, so the 1 and the minus half give us a plus half.
It's always going to be.
This is a perfect square trinomial, if you will. Even though if you want to, this is going to be y to the 3rd plus 1/4
Oh, it's just like our original.
y to the negative 3.
Oh, yes, there's a shortcut in here.
So now what happens when you square a square root? It cancels. So we have this.
1/4.
So that was kind of the trick to to doing this one by hand. Otherwise,
Wait.
it's,
Our dx dy is the same thing.
It's not the same because it's plus instead of 1.
Yeah, it's one that's. Is there a shortcut? The letter.
Don't lie.
I don't think so.
There is, there is.
I
There
don't
is.
know. I don't think so.
You can't play the fifth on this one.
I don't know, guys. Oh, what do we have here? So it's going to be 1/8 minus 1/8, right? With a y to the negative 2. evaluated from 1 to 2. And
The fourth is what?
Wait, how are we supposed
I'll just-
to do?
I'll just tell you that it's 130, 123 over
Yeah,
32.
because we can do that by
On a
hand.
test, if I would really need 12.
Yeah, I know.
That took me a good 45 minutes. And I'd
That one
say
was hard. I told you I'm just going to look for the setup and using your calculator for the test. There are a couple homework problems that they want you to simplify, kind of like these first,
So we just
to try to do it without a calculator.
and then if we can't use it.
Okay.
What's the answer?
Oh, 123 over 32.
1, 2, 3, 3, 2.
So if you look at the next page, we have vertical tangents, corners, and cusps. What are special about those?
They're not differentiable.
They're not differentiable. So sometimes they have a place where the derivative is undefined, okay? But we can still find the length of the curve.
Why do we want to find the length?
So how will we find the length of the curve? You're going to break it up into parts, right? So if I have, for example, a cusp, let's
Why
say
not
like,
just change it to a function of y?
you can also change it to a function of y. So you can either break it up into parts, so there's two ways to do that. So if we look at this curve, this is a cube root of x. Cube root of x does have a vertical tangent right here at 0. So if I want to find the curve from here to here, there's actually many different ways we can do it. We could figure out the length of the curve from here to here and then double it because it's symmetric, right? We could define the length of this and add, or we
Wait,
could
is
change
there
it to y.
X equals y cubed.
That's what Jordan was saying.
Is there
We could change it to,
I said that was Jordan.
Is there anything that deals with, because integrals in negative can be negative, so when finding the length, is there any, like, you know, if the line's under the x-axis is it a negative integral that we have to do?
Well, length can't be negative. So it would always be some value.
We have to do something differently when it's under x-axis. No.
it's okay if it's under the x-axis. Okay, so if I change this to y to the third, a cube function that doesn't have a vertical tangent, doesn't have a cusp or corner. So we can use the same approach, but do that with,
What would you do? Like,
I would do this. So dx dy would be what? What's the derivative? 3y squared. So then if I square that, I get 9y to the fourth. So now my length of my curve, what are the bounds going to be?
0. Isn't it -2 to 2?
Yeah.
Because we changed everything to y,
Using the y.
and then we do square root of 1 plus 9y to the fourth dy. Now this again, there's no way to simplify this without the calculator, so this you can just plug it in. And
Wait, there's no way, but we could do the other ones.
the other ones we were able to.
This one was a lot easier.
Right, but this isn't a perfect square. So that's the one reason why we were able to simplify the others.
We can't do either side.
Why are the x the bounds?
No, because you needed a y to the third on the outside.
Why are the bounds negative 2 to 2?
I got 17.6.
Because of the y. Because we changed everything to a function of y, so we use the y. Look at the original function. I actually think it's easier to look at the original. Use the y on those values. Anybody get 17.261? Great.
Wonderful.
All right, so
But if we forget how to do this, we can do it the other way in the template, right? We just only do one part.
yeah, that'll work.
Cool.
Okay, so here's another curve. It has a corner at 0.
What's a
You
corner
know what
versus
happens
a
if you get
cusp?
the... What happens?
Okay, cusp is very specific. That's the even over odd. This doesn't have an even over odd. It has a different slope from the left and a different slope from the right.
So when it's not
Cusp is when the slopes approach a positive infinity from one side and a negative infinity slope from the other.
and that's why it doesn't have a limit at that point.
Right.
Um,
The derivative doesn't have, yeah.
So that would be considered a corner?
This is a corner because from the left and from the right, it's approaching a slope that's not positive or negative infinity. It looks like a cusp. Bless you. Okay, so here's what we want to do.
Piecewise.
We want to rewrite it as a piecewise defined function. So where did it change? When x was less than 0, and then we want greater than or equal to 0. So what happens to the left side?
It's like a parabola.
It looks like x squared
Down to-
plus 3x. Why do I say plus 3x?
Because if you put in a negative,
Right, if I put a negative value in, right, you'll end up with a plus 4x minus x, so that gives us a plus 3x. Do you understand? Look at the original function. Okay, but if you're looking at the left side to the left, this is going to be positive, and that'll be minus x. And then if we look at values greater than 0, then we're going to have x squared minus 5x. Let's just think about, remember when you had absolute value of x was equal to negative x when x is less than 0, and positive x when x is greater than or equal to 0. So imagine if you could take this part and replace it with a negative 4x versus a positive 4x. Or actually not even the minus, like this part. Okay? So what does this mean? This means here, what's dy dx of this part?
Why is the negative? Why is the when we put in the negative value of x? Oh, okay. Gotcha.
Yeah, I would think that.
Because that's below 0. That's the negative value of x.
I thought it would be minus 3x.
But for values less than 0, it's going to be minus, and it's going to be a negative 4x. So it becomes plus 4x. So what's dy dx of this? This is 2x plus 3. What's dy dx of this part? 2x minus 5. So now we're going to evaluate the length of each part and combine the results. So the first part's going to go from negative 4 to 0. This is calculator, so this would be calculator okay. So it's 1 plus 2 plus 3 squared dx, and then, did I say it different? And then I have from 0 to 4.
But if this is a continuous function, then why
It is continuous but not differentiable.
But I mean, it has endpoints. Then why didn't we just say from in our piecewise function, when from like negative 4 is less than x, which is less than 0.
I guess I could have asked. You want me to go fix that?
I mean, wouldn't that technically make sense? Just mathematics.
Mm-hmm. If you look at the graph, they don't look the same?
Now that I'm looking at it.
Okay, so what's wrong?
for the prior problem, what would have happened if we didn't change the y equals x 1/3 to x?
We could break it up the same way we just did this one.
Because it's a vertical tangent.
Yeah.
So you have to change.
Well, actually, let me think about this, because you'd still have 1/3. You'd still have x on the bottom. No, you couldn't do that then. You have to make it into y. So,
Why so?
because when you take the derivative of something, if you have x to the 1/3, you'd get 1/3 x to the negative 2/3, which would put x in the bottom. Remember, you're evaluating it to 0, and you'd get something over 0 then. So it'd be undefined. So you have to change it to y.
So when we have something that's not differentiable,
Yeah.
then we have to.
So maybe we should look at the.
So your choice is either to do.
Oh, we're almost done.
Your choice is either to set x equals solve it in terms of x, or do it by parts.
Yeah, I was just thinking maybe to look at the homework and see which ones you have to do that for. So your homework tonight, does somebody have that?
It's 1 through 13 odd. Starts off with that.
Okay, 1 through 13 odd.
On page 416. And then 21, 35 through 37.
1 through 13 odd, and then which ones?
21. And then 35 through 37.
Okay. So, numbers 1 through 10 are all calculator problems. Whenever you see this N-I-N-T, that's a calculator. So, really, I'll set up an integral for the length of the curve. So, for like part A, that would be L equals, what would that be from? They give you the bounds. This isn't, we're just using the formula. So, -1 to 2. Nah. Just do A and C. 1 plus, what's the derivative of x squared? 2x, so you could just do 2x squared dx. So that's part A. And then for part C, just plug that into your calculator now.
Do we not circle our answers then? Or just go to C?
Just go to C. I don't know why it says graph the curve to see what it looks like, as if you don't know what x squared looks like by now.
Do we have to write it out as A
Touchdown!
and C, or can we just write out the integral and then?
That's fine. So what do you get when you plug it in? I don't know. Something. Did anybody plug it in? Let's see where they put the answers. Did they put the answers here? They don't have the answers for some reason. But you guys understand what to do there. Uh-oh.
Blankets of an asteroid.
So, all of these are going to be the same. Just do A and C only. Good. When we get to, oh, and then we had till 13. So 11 and 13, you're supposed to try to do by hand like we did the ones in the packet.
Why did they make the most complicated? Oh, because it's going to be a perfect.
They're trying to tell you that once you simplify what you can, it turns out to be a perfect square.
6.12. How
Do
many?
you give us
Can we do 3 decimals?
3 decimals.
6.125.
These you're supposed to find the exact length. So try these without a calculator. These are the two that will take the most work.
Can you go back to the beginning ones? We can do it
Oh, you want to just go through them? Okay. So what did you get for C for this one?
6.125.
Okay. Then what? You're on number 3? So number 3, what's A? What's L? Go from 0 to pi, the square root of 1 plus what? So the derivative is going to be cosine of y. Good. Cos squared y. Wait. Yes. And then dy. And then for part B, you get whatever that's equal to. She'll do it.
What page is this? 0?
For that one,
What?
Is there a lock-in for calculator
for 5.
Oh, I got 3.82.
3.02?
3.82.
3.820. Perfect. Okay, so number 5, yeah. So look at, number 5 has x and y on both sides.
Oh, no.
So what we have to make a decision is if we're going to do dx of both sides or dy. What do you think?
Yeah.
There's more Y's than X's.
Look at the bounds. They go from -1 to -1 and 7 to 3. What do you think? So they gave us both.
I think we should take Y.
Y, D, dy.
One of both of the X's and one of them is both the Y. No.
Let's try D, dy of both sides. So for number
Y's
5,
and X's.
so that means I'm going to treat Y normal, but when I get to anything with an X, when I take the derivative, I'm going to have dx, dy. So this is going to be 2y plus 2 equals, this is going to be 2 dx dy. Oops, not dx dx. Plus 0, right? Yeah, that looks like that would have been a lot easier to solve, because otherwise, if you did it the other way, you would have had to factor out the dy dx. So it looks like if we just divide everything by 2, that'll work, right? So it'll be dx dy is y plus 1. So now L is going to be, since we have y plus 1, we want to use which bounds? So I want to use -1 to 3 of the square root of 1 plus y plus 1 squared dy. It's thinking. 9.293.
Sometimes I mix it up. Sometimes I truncate, sometimes I round.
Okay.
I'm so versatile.
Truncated once saved me from a tardy.
Okay. All right, next one. This one is defined as an integral. So what do you think?
The integral just the function itself.
So it's tan.
It's just
So we're going to do d dx of both sides, so you're going to get tan x.
so it's just tan.
It's just changing the variable. Remember when we
Yeah.
do it that way? Can I erase this stuff?
Yeah.
Because this is getting a little messy.
Is that 10x plus 6? No.
So how much more is the stylus, Jordan?
The stylus is 60 and the
Make this go
keyboard
by.
is another 120.
For what?
The
This.
I don't know.
Keyboard?
Yeah,
You
it's,
paid $120 for a keyboard. You out of your mind.
That's how much they cost. You have to buy one anyway if you get it.
Exactly. But you already had one.
Hey, Jordan. My computer comes with a keyboard.
yeah.
That's true. Okay, so number 7.
Yeah, my name already
This
wrote
is the old keyboard.
Oh, yeah, we want to do d dx of both sides.
Oh, yeah.
So we get dy dx is what? Tangent x. Oh, is it time to go? So now L is from 0 to pi over 6, square root of 1 plus tan squared. Great. Look at that. See? This wasn't too bad. What's that? Secant.
Squared, tangent to secant squared.
It doesn't really matter.
Is it minus? Plus secant squared, yeah. Okay, good enough. We're done.
0.54.
It would be awesome if we could stay here and do the whole assignment.
We can finish together tomorrow.
0.49. What is
Yes,
silent
I-
numbers?
17.
What if we do this tomorrow and the practice test on Monday?
Because I made the practice test longer than I made it longer than it
Okay,
the actual test.
It's not gonna be on the pattern.
The actual